And here we are. We've made it to double digits on the All Things Facade podcast. And we have Manny joining from the one place in the world I'd probably rather be right now than New York, in Florida. And what did you say that you live on your own island when it comes to hurricane codes and designing facades? So on this episode, we're really going to dive into the Florida market, designing facades around hurricane codes, especially dealing with large and small missile impact systems and so forth. So before we get into all that, Manny, I'm going to give you a minute to introduce yourself.
Adrian, it's a pleasure. Manuel Morales with Facade Envelope Engineering Consultants down here in South Florida, 20-ish years now. Facade's been around just 11 years. And yes, it's our own little island. I mean, we're complaining about, is it 60 degrees Fahrenheit weather? We're all bundled up, and here we go. Now it's 70, so today is a nice warm day. But yeah, we can get deep into the technical right away, or we can kind of go a little bit into more of our background, whichever you prefer.
Well, yeah, I think it helps for everybody to have a little bit of context about your background. So Manny is on the facade consulting side, but he is a practitioner as well, having spent a lot of years doing investigative work and inspection work. So maybe you could share a little bit of that.
Absolutely. I started off as an inspector actually about 20 years ago for another consulting firm. And it was, lucky for me, it was everything building envelope. It was glazing, it was stucco, it was paint, it was roofing, it was waterproofing, basements, you name it. I was always building skin. Went into the consulting mode, have done a lot of field testing. And then right before I started this firm, I started doing curtain wall engineering. And in fact, when I started this firm, that's all we did. It's a one-man show from a little bedroom. It was like, I can't go out doing inspections. I can't go out doing testing. I don't have consultants. Just start doing CAD and engineering and start designing glazing systems and setting up test protocols. So it opened us up because it allows us to put projects on our website, basically. So luckily, most of the jobs we did were high-rise projects. Most of them were really high-end, luxury buildings. And we got to say, we designed that first-of-a-kind product. We designed this first-of-a-kind product. And always, they had to be impact-rated, large missile, small missile, and meeting all the hurricane codes, which is, today's main topic.
So I'm really going to be asking a lot of questions. This is going to be very educational for me, too, outside of the audience. Before we really dive into Florida and that sort of 500-pound gorilla of what does it mean to have a Florida product approved system, how would you really describe to everybody what qualifies as a hurricane zone? I've actually seen certain portions on the coastal area of Massachusetts qualify as hurricane zone. Looked at projects over here in the coast in New York, particularly along kind of by Long Island, that's qualified. So what areas of the market are we really talking about? And is that code driven or a preferential treatment? How could you better describe that?
So you would look at ASC 7. Obviously, I understand you've looked at that before, the minimum loads for buildings and other structures, and you'll have your seismic loads and you'll have your wind loads, which is what we would be talking about. And that's going to talk about your category 2, 3 buildings, and then within that you'll have hurricane-prone regions, wind-borne debris regions, and then that big scary gorilla, which is the high-velocity hurricane zone, which we'll get to in the end. So hurricane-prone regions, and just going by memory, we're talking about, obviously Florida, Puerto Rico, I believe it's American Samoa, Hawaii, and as you mentioned, it's wherever the wind loads, the basic design wind speed, and that's why I mentioned category 2 or 3, the basic design wind speeds, the number I remember is either 130 mile an hour or 140 mile an hour. Anything above that would trigger being a windborne debris region. And the idea is that you're going to have enough wind speed to pick up debris and shoot it into your building. And that's where the impact tests come up. And that's where you have the difference between large missile impact and small missile impact. A large missile impact can only be brought up, according to the code, up to 30 feet above grade. So you're worrying about that, famous 2x4 getting picked up, shooting into your window up to about your 3rd floor of your building height. Anything above that, you're thinking gravel, pellets, and that's why the test of small missile is steel ball bearings, right? So again, as you mentioned, it's code driven and it's tied not just to the code. The code obviously relies on other standards, and in this case is the American Civil Engineers Standard 7, which used to be one chapter 6 on wind loads. Now it's between chapters 26 and 30 something. So it's been expanded a lot more. as you know, it's changed. You'll see that wind speed map between, I think, 2010 code or 2007, 2010 change, because they changed from allowable stress design, which is what a window contractor or manufacturer would look at, to ultimate or strength design. So there's a variation in the wind speeds, but when you apply the load combinations, it just goes back to what we were dealing with before, right? That they didn't drastically change.
So I had dinner with somebody a few weeks ago that kind of brought this to my attention. To be honest, I wasn't thinking about it, and they brought up flood zones, especially on coastal areas and hurricane zones, and basically how the climate, it really is starting to change, give a shift in building design and just holistic planning altogether. And then when Clark Pacific came on, they were really talking about resilience, especially in their earthquake and seismic zones. So do you think this is gaining more attention? I mean, I've seen hurricane zone come up all the way into the Carolinas, and so do you think this is more prevalent now than ever?
I think that's an interesting word that I'd have to look again to see if the standard calls it resilience, because really that's what the test is. It's not testing to be hurricane proof. It's hurricane resistant. You're going to shoot that window. You're going to actually break that window. But what you want is that during that hurricane event, it stands in place long enough for you to, wait for the hurricane to pass, and then gives you time to replace that window. So the window breaks, you cycle the window 9,000 times, at least for our code. And that's, I saw somewhere some presentation that's the definition of resiliency. It's how fast can I get back into that building? How much was destroyed of that building? How soon can I make it operable? And that's really what the standards are about, I think. As far as, I think insurance has something to do with it. So the insurance carriers are taking the big brunt and are really driving, these code changes. And what you get here is, as soon as a hurricane comes through, then immediately, the clock starts ticking of when you can present an insurance claim, basically. So I think it's in their interest that the codes are improved to limit the cost of both insuring but also repairing these properties. And the proof is in that. You've seen the Instagram post of buildings that we had during recent hurricanes that they're working. Basically, if you take where the code came from 1992, Hurricane Andrew, and really that's when it changed. All our test standards for Miami-Dade and Broward are -94. So they haven't changed since 1994. We've got the same impact test sequence and cyclic test sequence that we had back then. And like I said, I've done projects in the Caribbean, and the same thing. The windows and the railings, for that matter, will perform as expected, meaning that yes, they might break, you might lose a couple, but for the most part, they'll stay in place and protect the interior of the building. So again, as the code progresses, I also recently found out that our ASC 7 let's say it's 20, maybe 21, I don't remember what year it's in, is including now tornado loads. So now you have to do an analysis for tornado loads as well. What I understood from that presenter was that for our area, for South Florida and most of Florida, it may not impact anything, because you will have to compare it to the hurricane loads, and then you're going to take which one controls. Is it tornado or is it hurricane? But potentially for the rest of the U.S., especially Tornado Alley, it's going to affect how these buildings have been designed, right? And especially for our cladding and window elements. So that's definitely new in the code.
You said one thing that stuck with me: glass deflection, and I have a story I want to tell you. I have trouble wrapping my head around is meeting performance specifications and codes versus what's going to actually be comfortable for the occupant. And so you see a lot of specs that are either designed to 3/4 of an inch center of glass deflection or 1 inch. But the question is, what does 1 inch of glass deflection actually look like in real life? So I went to look at a job recently, and it was big, large fixed lights, insulated glass. And I think the center of glass deflection came out to like 0.79 inches. But if you went to the center of that unit and pushed, you felt that wobble. And so the unit was structurally glazed. It's not going anywhere. It was captured. But do people really understand that? I guess, is it more of an occupant safety or comfort standpoint, and the balance between when a system is actually going to fail? I can imagine in a hurricane zone, you talk about that cyclic testing. So when you see those high winds in Florida, 90 miles per hour, can you see the glass wobbling?
Yeah, exactly. So two questions in there. The serviceability analysis, right? It's difficult to understand on paper until you're living it. I've gone to projects that we engineered, and as soon as they say it's a glass railing with no handrail, I pull my kids away from the railings. And I know that they were properly engineered and everything, but there's a comfort level there that I just can't get, especially with glass. When it comes to that glass deflection, and I'm licensed in Florida and in New York, so I do engineering for both. Florida by default, especially the windborne debris region, is going to be laminated. So immediately there's a safety factor there that if it over deflects, even if it were to spontaneously break, because glass is brittle that way, I'm still, I still have another layer, right? There's no chance that they both could break just because of deflection. So again, I think I mentioned before, hurricane takes precedence over that, call it serviceability analysis. So in this case, you're designing the glass for your hurricane load and your impact, which you can't design for, you have to test for impact. And then you say, well, if I passed the impact and cyclic, I'm not going to make you limit that glass deflection. I'll make you limit the frame deflection. So if I'm doing South Florida, it's L over 180 versus L over 175 everywhere else. And I don't have the option to do L over 240 plus a quarter. I have to do L over 180, no matter how tall that frame is. So that's one of the limits that Miami-Dade is going to give us. But then there is no mention of what is my glass deflection. I can measure it, but there's no pass or fail criteria for it, because it becomes economically unfeasible. It becomes unbuildable. You can't even carry it. If you think about an operable system, that you're having to design a pane of glass thick enough that at 175 mile an hour winds, it's not going to deflect more than 3/4 of an inch, especially with our trend is for taller, wider pieces of glass. Our trend is for more glazed area versus less glazed area. So it's they're going in opposite directions, basically.
So it's interesting that the next topic I want to get onto is laminated configurations. And so obviously we don't really see it much here in we see it a lot in New York because of OER, we have acoustic requirements. So in a lot of cases, whether you're on the West Side Highway or in Midtown, have to incorporate a laminated configuration just to meet the OITC requirements. Elsewhere, I don't see a ton of LAMI. In Florida, because you need it, because of the hurricane requirements, has it become very readily available? It obviously can't be cost prohibitive. So do they look for cost savings elsewhere, or is just the baseline for what they spend on facade systems assumed that it's at a higher price point?
Yeah, automatically. It's interesting because we're working on other topics, and obviously I've been following the work that you're doing. There are things that are happening everywhere else, and that's where that island phrase came in. Everywhere else is in energy, in acoustics, and user comfort. Florida did a drastic change with the disaster of Hurricane Andrew, and it beat everybody else at hurricane, right? So, but obviously there was pushback back then, to get it incorporated. There was a transition period between what was obviously the South Florida Building Code, where Miami-Dade and Broward had their own code, to now this uniform, combined code. It wasn't easy, right? There was cost. There were developers that would have said, I'm not building there anymore. There were probably insurance companies that must have left, the same way that we're seeing them now with it's hard to find insurance down here. But there is no owner that doesn't understand today that it's going to be laminated glass. And your option is, again, if you look at ASC 7 of the building code, it's either you put shutter protection or you put laminated impact rated glass. And it makes no sense on a high rise, I'm going to start installing shutters. Even though it is a solution on projects that are existing, people, instead of replacing their windows, go up and put metal shutters or accordion shutters or roll up or whatever. So that's really it. It's ingrained already into our design. An architect automatically will say impact rated windows and not ask any questions.
So I told you before we started this conversation, I want to focus outside of just glass, but I feel like I have so many conversations in that itself that could last for hours. So let's just look at the glass makeup before we get to the frame and then surrounding opaque area. It's assumed it has to be LAMI, and then the thickness of that inner layer, whether it's 060, 090, is going to be based on small or large missile rating. When was the transition between a single LAMI and then when insulated LAMI became commonplace? Or is it not there yet?
Not there yet. So if I can, and remind me of this question in a second, there is a topic that I think will help, and obviously I think it'll help you as well. So in your field, you're testing already, I'm assuming. You're doing air, water, and structural load testing. And you're doing this automatically in any project for all your systems. You're following AMA 101. The only difference we're doing is we're adding an impact in a cycle. We're still doing air, water, and structural load testing. It's almost identical. If you look at, I think, we talked about before hurricane versus windborne debris. Most of Florida is windborne debris. Probably at Orlando, there's kind of a dividing line and it kind of goes diagonal. And then you have this phrase of the high velocity hurricane zone. It's just a fancy name for Miami-Dade and Broward. It's not higher pressures than Monroe County, where the Keys are. I'll get higher wind loads in the Keys than I get in Miami. But Miami-Dade and Broward always had their own code, and that's still the case. So now, if you read our Florida building code, it'll say, chapter 24, this applies to everywhere, except that areas in the high velocity hurricane zone follow these few paragraphs. And then you have to go to chapter 2 and say, what is the high velocity hurricane zone? To say Miami-Dade and Broward, period. That's all it is. So if you look at AMA 101, that's mentioned in the IBC, and then you go to AMA 501, which is kind of the one that builds our test protocols, it gives you an option for impact of ASTM 1996 or 1886 versus Miami-Dade and Broward saying, no, we want you to use TAS 202, 203, 201. And they're just what Miami-Dade and Broward modified back in 94. So for example, if you're doing your load test for, I think it's ASTM E330, that'll do, I believe it's 10 seconds. TAS tests will do 30 seconds, right? The 1886 or the 1996, I can't remember which one it is, they'll give you a range of impact missiles, basically, right? So level D, level E, et cetera. TAS standards for Miami-Dade are one impact option, one speed option. Obviously level E supersedes that one. So whenever I have an essential facility, I have to shoot it with a bigger, faster missile. So I wanted to get that in there because it's not different to anything else or anywhere else. All we do is we add one or two more test sequences to prove impact resistance, because we can't prove that through engineering. I can't demonstrate that after I break that piece of glass, I cycle it 9,000 times, it's going to remain in place. And that's really what the test is. That's the whole resilience that's just going to stay in place.
Do you think we'll get to the point where you can engineer that through simulation?
I think because of the nature of glass, not realistically. So the whole story is glass is very flexible, which is where that deflection criteria comes in, but then it'll snap. There's no yield point to glass, right? So we have the allowance for, what is it? 8 in 1,000, I think it's our permitted breakage per ASTM E1300. So I think that's going to be the limitation, right? That the glass is unpredictable, and you take empirical data saying, if I break 1,000 pieces of glass, if I load 1,000 pieces of glass to this load, 8 of them are expected to break. It's not that it won't break; it's that less than 8 of them are expected to break. So for that reason, I think it's not you're not using the Young's modulus or a flowable element or a yield point. It's just a brittle failure, basically. So and that's putting it in a lot of words to what the local jurisdiction, that they're just going to say no. Their answer would be, you think we could do this? And they're flat out going to say, absolutely not. Prove it to me through testing, every single time.
So in essence, the point of the testing is that missile or something, a 2x4 hits the glass, it's going to break. Because you have the inner layer, it's going to stay in place. It's whatever, adhering to the interlayer. But the point of the testing is that glass will not dislodge from the frame. That's ultimately what you're testing, right?
That's exactly it. You cycle it to show that it doesn't tear, so you don't create an opening through which air or water can pass, or that it doesn't pop out completely out of the frame, basically. So that's it. That's the magic behind the South Florida testing. That's the magic behind an impact-rated system. Everything else is what we're already doing to every other window. Every project you've got a PMU. Why don't we have a PMU? Why can't it be built into the design and the cost and the timeline of the project? If you want to do, for example, new systems, which is really where I kind of try to bring this to people's attention. You don't have to always take off the shelf. You can build a design and a test protocol early on in a project, which is what we did for the first few years. Was client would be, an out-of-state architect and say, this is what I want, guys, and my building's 60 stories tall. I don't care. Just give it to me. And we come in there and say, all right, here's the glass you need. Here's what you need. Let's quickly get into the lab. Let's test it. and we start the product approval process while they're already getting, window permits and things like that. So it was.
Well, that's my question is, if you're designing in a hurricane zone, let's say in the Northeast, you have to do that testing easily. You can easily do it at a lab. It's fine. You check that box, pass. In Florida, there's this whole other step of getting through the product approval. And then if you're going through Miami-Dade, whatever else is involved with that. So before you talk about it, what was kind of the history and point of that? And I guess, does that dissuade or discourage designers from going custom because they'd rather pull something off the shelf that's already pre-engineered, pre-tested, and approved? Or how does that sort of, that kind of work?
I'm young, right? So 92, I was 12, basically. I wasn't here at the time. What I can understand is that there wasn't enough QA, QC. There was no control. There was no way to control what windows were being installed. Even if it was tested a certain way, how do you prove that that's the window that was installed? So the Miami-Dade County Division is not just reviewing and approving your product approval. They're also doing quality assurance visit to your shop, right? They're visiting the laboratory. We're a certified lab. They come every year to our lab to make sure that we've got the equipment, we've got the trained personnel. So it's a lot of that QA QC process that's built into the Miami-Dade, call it bubble, right?
So they have people coming out verifying systems on site, and they're willing to take on that liability?
Not on site, at your fabrication. So you have a QA QC procedure. I think. So yes, the answer is yes, but not to construction sites. So they're not going for installation, they're going for fabrication. That's about it. And they're going to the test labs as well, because every lab has to be certified, especially for the Miami-Dade tests. We have to do the TAS 300 basically certification, which again is a Florida or a high velocity hurricane zone standard.
So who is on site verifying that install?
It could be anything from, if you're doing single family residence, it's just the building department. If it's a high rise, the building department will default to a special inspector. So you'll have
you have special inspections in Florida.
Yes, absolutely.
Okay, because in New York, obviously we deal with that, and you're not getting your TCO unless you have your technical requirements or TR document signed off by a licensed professional.
And he won't sign off if you don't have, for example, when you go for permit, you need that NOA or product approval with your permit application, and which is, I think, where your question was going. How long does it take? Is it a deterrent to design new systems? There's the alternative is also there's the Florida product approval. So you have the Miami-Dade product approval, and then you go to Florida State, Tallahassee, and you apply for what's called the Florida product approval, and you can do it that it is compliant with a high velocity hurricane zone. So you do the TAS testing, or that it is compliant with every other part of the windborne debris region, which is the ASTM 19 and 18 tests. The process is different, tends to be faster, but if you have a project that has specs and the specs say Miami-Dade NOA, you have to get a Miami-Dade NOA. If it just says get an approval, then you can go for either or. I guess now that you're here, let's say if I'm a glazing contractor and I'm down here, number one, I'm not going to tell you all this because I don't want you to come down here and compete with me. Number two is if I've got a bunch of windows that I spent money testing them, and then the architect comes in and says, well, I don't want that, I want this, I'm going to say everything I can to dissuade them from doing it. I'm going to say, my NOA doesn't allow for this. My NOA doesn't allow for that. So that's what you'll get. We are doing a lot of, obviously from our consulting side, we're consulting for a lot of out-of-state architects. And usually we say, yes, you can, we'll have to test again. Right?
Yes, but my question becomes the New York and Florida markets are so unique relative to the rest of the country, let alone New York versus Florida themselves. And in New York, what I see is every single job requires some type of modification to the window. And I think a lot of designers have taken on that mentality. You'll see 400 different window types on a project. You'll never see that in some other markets. And designers have taken on that mentality because if you don't want to do it, there's somebody else that's willing to do it.
Yep.
And so do you see a lot of competition coming into the Florida market and people willing to do things they previously weren't willing to?
I can count from the locals even, I can probably count 2 or 3 people that are those that'll say yes to that architect. Yes, I can. Yes, I will. But then there's a price for it. That's all it is, right? So you'll get the architect and maybe sometimes the developer, usually it's the architect saying, here's what I want. give it to me. And a couple of the local guys will say, of course I can do it. But the price, the owner comes back and says, what else do you got, right? And then they go back to, here's my off-the-shelf one. So there's a lot of stuff that gets VE'd out, and there's a lot of bidders that just don't work in that realm. There is a, how do I put it? We're still busy. We're still very busy. We haven't really felt the pinch of what I think the rest of the country is going through. And so you as a local guy, once you've gone through that process of getting a few product approvals, there's not a big incentive for you to come out of that comfort zone and say, look, I went through all this process, the cost, the time, got the product approvals, buy my windows, well, I'll go to the next guy that'll buy my windows. That's really what it is. So in our market, the first thing is whoever's coming from outside is probably thinking about it like you, like, oh, this sounds difficult and possibly impossible. And then only a few engineers are going to say, it's not that hard. All you have to do is just add this. Let's go. You know, it's a conversation that I've had, not just with you, I've had it with a lot of people from out of state.
Yeah. All right. So I felt you brush off that energy topic when I mentioned insulated glass. And I know Florida people don't like to talk about it, but a lot of the people I've had on this podcast and that I interact with are so energy focused, especially because I'm in the Northeast and we're in a heating dominated climate. When you go south, there's this misconception that E value doesn't matter. R value doesn't matter. I was meeting with a contractor in the South trying to describe to him how window wall is built. And he said, okay, you have your framing and the glazing from slab to slab, and then you slap on a piece of metal onto the slab. And I said, well, how do you insulate it? And he said, why would you insulate the slab? And I was mind blown, but that was not strange to him to ask that question. So you said that you still see a lot of laminated configurations alone, especially on new construction. Is the market just not adopting insulated glass? And I guess a better question would be, does U value matter in the South in a warm climate?
So talking about U value, a short answer will be, when I talk to mechanical engineers and energy models, because we are not, that's not part of our scope, they want the value, but they say what's really affecting the final load calculations is solar heat gain coefficient. So I've got a window here. You'll see me do this a lot. This time of day, it's my AC is cranked up over here, so I'm cold. My hands are cold, but then I've got this heat furnace right here, just getting my hair all in a mess. That's standard for Florida. I've gone to LEED buildings, LEED certified buildings from probably 10 years ago, met all the points and did everything they were supposed to do. And same thing, people are chilly on this side, and then they've got pieces of paper on their blinds essentially because they can't deal with the glare and with the heat gain on that glass. So the solar heat gain coefficient overrules and really creates the energy costs for us, right? Way more than what U value would affect, right? When I'm having the discussion with owners, it's if I have, let's say, an office building, like a luxury, we're doing a couple of luxury office buildings, and we talk about condensation risk. And we say, look, if you just do laminated glass, expect that you're going to have sweaty windows every morning, especially if you have people working at night, kind of deal. If you do insulated, then potentially you can reduce that effect. South Florida is selling views, right? We're selling Instagram pictures essentially with every building. So every building is, 360 views. You're not going to worry about what's north, east, south, or west. You're going to put windows on every single one of those elevations, and they're going to be full height windows, and that's what's on every brochure. And then they're going to say they're impact rated, they're soundproof because they're all laminated. You work with the heat, you deal with the heat. We'll just crank up and get a bigger HVAC system, and that's really the default here. I am having side conversations, I know, with colleagues that we both know, and we're training ourselves beyond that, right? A lot of our clients are not from Florida, so we're training ourselves beyond just the hurricane rules. Forget about energy. As long as we meet hurricane, everything else, if it's a code conflict, everything else gets put to the side. And sometimes it's not a code conflict. Sometimes it's just a cost, and especially for, let's say, window replacement, which I think you do a lot of. I've done specs for window replacement jobs, and automatically I go, I'm not a mechanical engineer. I'm not doing an energy model. I have to default to the prescriptive method, which says you factor this and as solar heat gain coefficient that. My client will go back to the building department with that, and the building department will say, I'll bypass that as long as you give me impact windows. So I've done projects where the owner is allowed to do laminated only, even though I'm saying per code it should have been laminated and insulated if I'm doing prescriptive method, right? It's really that.
Have sweaty windows just become acceptable in the norm?
Oh, yeah, absolutely. It's The only
Even
time I
in
get a call,
high-end new construction, I'm selling this fancy condo, your windows are going to sweat, and it is what it is.
exactly. And what I've found is that the only time I get calls is when it's sweating on the inside, which you have a different issue there. And it happens a couple of times every 2 years when we get that, South Florida winter, cold outside. I've got my AC at 72. Now I've got the sweaty window on the inside. I don't have drainage for condensation risk, basically, because we don't get it here, right? That's the other conversation is we're all barrier systems. And again, this is how we keep all the other guys out. We say, we tested a barrier system. There's no way you're adding a sill pan to this. We tested a barrier system. There's no way you're modifying my system. If you want a different system, I have to go through the full round of testing, from scratch. So owners and architects are scared away from modifying and improving on glazing systems down here. Basically.
So is the question of, if you just look at in terms of operational expenses, you have heating, you have cooling, you have plug loads, building controls. The cooling expense, is that just kind of a sort of another one of those built-in assumptions that, you own a condo and a high-rise building, your utility bill is likely going to be this, and that's just standard across the board?
It's expected. How do I put it? I'm having conversations with the local climate tech hub. When I met you up in New York last year, I saw all the grades of the buildings. I said, look, they're shaming buildings into doing this. And I told them this yesterday. I said, as long as actually, let's go back 20 years. So
we're bringing bullying back in New York.
Yeah, absolutely. And then you're finding that at the end of the year with local law, 97? So it's either you're going to be embarrassed because of that D grade shown on the front door, or you're going to be paying more money because you spent more energy than you had to. We don't have any of that out here, basically, right? And what I found from a local energy consultant is that she was doing analysis in another state, and she's allowed to use different software that actually lets you optimize the energy model. As I understand, and again, not my field, the local Florida energy model does not allow for that. So as long as you're able to hit those numbers on that table, you're fine. You've met code, and that's it. As far as user comfort, here I am, cold hands, sweaty, this thing. So until we're able to, actually, no, I was going to go back 20 years. Hurricane Andrew hits, disaster, code changes, and it was a drastic change, right? It was night and day. So Florida showed that they can do it. They can change things around. We have the other catastrophe of the Champlain Towers and Surfside, code change very recently. I now know that there are things in the code that weren't enforced before that are now being enforced, and there are things in the code that have been modified. Florida can change, but at least the two examples that I've given you have been after a tragedy. I don't know what climate-related tragedy other than hurricane, basically, is going to lead to that, hey, we need to change this because we just had this tragedy. So what we're doing is it's educating ourselves, educating our clients, saying, look, I don't want to wait for the tragedy. Let's talk dollars and cents. This is how much it's costing you to keep this AC cranked all day, right?
So in terms of new technology, has dynamic glass made any traction in the market, especially mitigating that solar heat gain?
I'm doing some research on tax credits, basically. So that is, for example, I have a project where the windows are being replaced for insurance reasons. They had non-impact windows. I've been talking to that building for probably 4 or 5 years. Finally, the insurance company came in and said, you either do this or this is how much you're going to pay in insurance. It was cheaper to replace the windows to impact windows, not energy efficient windows, just impact, and just keep going. In fact, they're going to improve the energy efficiency because they're going to go to impact, and they're going to probably put a low E coating, but they're not going to take it all the way up to a insulated glass system. Sorry, I lost the train of thought there on the last question.
Dynamic glass.
Dynamic glass, yeah. So there's really no incentive to incorporate it if I'm barely doing low E coating. We're talking about just doing enough to, for example, if it's a LEED building, that I'm meeting that reduction in heat gain.
Right, but what about occupant comfort? And what about these big, fancy, office buildings or high-end condos? I'm just trying to think about, sellability for an owner.
Yeah, it's not part of the code. I agree with you 100%. And usually any project that I take, there's an interview like this. What are you doing with this? Are you flipping it? Okay, I know what you're not going to do. You're not going to do much, right? Are you operating it? Then I start talking about the cost to maintain, cost to repair, right? Just recently, I started talking to local architects that are saying, I wanted to perform better. I mean, this is not something that's ingrained in the local pool of designers. The local pool of designers are do the next project, do the next project, do the next project, because there's a lot of work basically. And the developers I count in one hand the number of calls that I got last year. One hand. There's actually one guy that said, no, I want a better performing building. Everybody else was, I want it to look good and I want to be able to make money out of it.
So let's think about just performance metrics. We talked about U value and solar heat gain, and what's actually driving the design of these systems. In New York, we have ventilation requirements. So operable windows everywhere in, especially residential buildings. Every room is very commonplace. How do you incorporate operability with windows, and how does that mix with these impact-rated systems and approved products?
That's a good one, because we ran into it in an existing building, and we have an issue with water intrusion. From the mechanical side, I think it depends if it's, especially in a high rise, if it's mechanically ventilated. I think they're allowed not to have operable systems. But at some point, we were always expecting that in sleeping quarters, there was always an operable system for like the 10% of the floor area for natural ventilation. And for shorter buildings or smaller construction, then I also have a secondary means of emergency egress in case of fire that I would have an operable system. Where it becomes challenging is in a few places. One is water intrusion, much harder to make them rated for water infiltration. Two is, especially in the case of casements, and I know you guys do a lot, you'll see that we do a lot of single hung windows. Part of that is that people forget them open. So imagine I've got it open, wind picks up, slams it over, that's it, that's the end of that window. And that would happen a lot, both with the pop-out ones or the project out and the casement. So we tend to veer towards slightly horizontal sliders or single hung. They don't look great. They always have another mullion or another vertical member, but it eliminates that fear of that panel's going to pop off and fall on somebody. Because
so I would think, and with the issue with single hung windows or just hung windows in general, again, is meeting energy code, but then acoustics becomes challenging, but also air and water infiltration. So if you're considering wind-driven rain, especially in a high wind zone, is that something you deal with a lot? I know you get on the leak investigation side of things. So in terms of, problem areas in the Florida market, it seems like you've resolved this issue, laminated glass, it's commonplace, but I'm trying to dig onto the side of where are the problem areas.
So we're about to break the internet. So you understand that Florida is seen by everybody else as the strictest code everywhere, right? And it makes sense because we're designing to a Category 5, 175 mile an hour wind for structural and impact. For water, we're still only testing at 15% of design pressure. So I always tell my clients, especially when they're doing window replacement, understand you're not getting watertight windows of any system. You're getting a water rated or a window rated for water intrusion at 15% of 175 mile an hour wind, basically. So again, it's a code limit. And I can't force somebody to design or pick a system that performs beyond that. The most I can do is if they're doing a new system, I can maybe make them test at 20% or more. Or I can pick systems that are in manufacturers as well that have a better track record at performing. So if I'm looking at sliding glass doors, I know whose system and which manufacturer has an easy to install, because that's the other thing we haven't talked about is it's labor. What door is easy to install, easy to seal, and easy to pass that water test. And again, 15% of the design pressure. So I bring that up because people always make that face you just made when I say it. They go, what do you mean? I go, yeah, this is it. You're not getting a watertight window. You're getting a window that during a hurricane event is very likely going to leak.
So are faulty, failing systems, whether it's sliding doors or in the event that you have an operable window or even just your barrier system, is that a big problem area in the market, leak investigations, especially I would assume the insurance claims in a condo building?
So what you'll have, especially after a hurricane event, all the window manufacturers go out and send notices to their clients, especially when they get a notice. They say, hey, by the way, here's what the code says. The code says that in a hurricane event, or even a tropical storm event for that matter, my window is expected to leak. This performed as designed. That's the end of it. When we get called in, and usually I'm not going to visit a project because of an event like that. Usually it's because it's failing under day-to-day operations, right? And it's active water intrusion all the time. So That happens not because of code, that happens less quality control. They don't hire consultants, they don't hire inspectors. Window guy comes in there, pops a window in, seals it the best he can, walks away. Nobody looked at it. There was no, it's not just the window guy, it goes all the way back to the design. There's no shop drawings, there's no architectural detail that really shows you how to transition from that window back to that wall. There's no air barrier on the wall, it's just stucco and paint. We probably should do another podcast on that, but there's that real quality control is not built into every single project. So when I'm called into, even in luxury construction, it's usually something that I can trace back all the way to design, to shop drawing, to inspection, to installation. Not one person that was responsible for that window leaking. And it's definitely not the code, basically, right? If they install it correctly, they'll pass the ASTM 1105 test, 05 test at full, the 15%. It's when they're not passing at that pressure that triggers the forensic investigation and the issues, basically.
Yeah, the reason I brought that up, hurricane aside, I mean, in New York, we designed to just incredible wind loads at corner zones and so forth. I'm talking like 80 mile per hour wind, crazy. And when you're testing these systems, either on site or in a lab in the chamber, they're really literally put under a lot of pressure, but put under a lot of pressure. It's tough for some of these systems to uphold. And then you consider now a lot of consultants don't want your field, 1/3 field reduction. Testing to 15 PSF on an operable window in the field, it's challenging.
Yeah.
So I'm talking, as you said, day-to-day operation. And if you're dealing, especially in something that falls right below a tropical storm, how could you not have leaks left and right? In high-rise construction under extreme wind loads.
Yeah, we nitpick at any system we see, right? And that's kind of it, right? So if you look at all the books that I know we both read, starts with adding overhang, right? Try to not have a flush down condition. We're working with an architect out of California right now, and they say we're only going to do pressure equalized systems. It's not as bad as it sounds. What I wanted to bring to your attention, though, that it wasn't, for water at least, it wasn't as strict as it is for everything else. It's just enough to get you that 15%. Water and air, I think we're doing 6.24 PSF as well. So I don't remember if that comes out to like 30 mile an hour or something like that.
So before I get to this, you're saying that sliding doors are common, but you obviously don't see a lot of project out or projecting casements, but you also don't see swing terrace doors, it sounds like.
Those are challenging because you need the high threshold. And then now you start talking about accessibility and ADA requirements, which are still an issue with sliding glass doors. So if you look at any sliding glass door down here, they'll have a big 3 or 4 inch tall interior sill riser, basically, because we're doing, head of water. And that's how we're managing, water for the sliding glass door system. For a swing door, you can't imagine a swing door with a very tall threshold. You'll have a French door. Do you use
pavers on the roof, basically, to get that level playing field from the interior to the exterior?
So most architects come in with their pedestal paver design, and then it gets feed out to a mud set application, and I have to figure out a way to drain my slider or my door over those pavers. But I know exactly what you're describing. I have projects now that finally they got through pricing.
And we're going in a direction I wasn't expecting. But with these pavers, I mean, do you have issues with uplift? And especially in a tropical storm condition, nobody wants that stone paver going flying onto the beach.
They need a product approval as well. That is
wow, paver product approval.
Yeah. So if you look at what's deemed to comply, it's everything that is on the outside of the building. Actually, let's correct that. The vertical, anything that's not concrete, CMU, frame construction, it's like wood stud framing, 5/8 plywood, lath and stucco, that's deemed to comply. Steel structures designed for the steel standard, and I think there's one more. I can't remember what it is. Those are all deemed to comply with impact resistance, so you don't have to test those. Anything else that you're going to put on that wall has to be tested, right? When you come to horizontal applications, all our roof membranes have NOAs. You have to have an NOA or a product approval. And then when you go to waterproofing, they'll say, look, wherever you had a roof, you can do a waterproofing membrane as long as it's tested and it has a product approval. And then if you have an overburden, they're going to want to see that overburden listed on the product approval. So pavers.
Now I understand why you have a job in a business.
Oh yeah, it's I tried to get out. I couldn't. I kept getting pulled back in. So yeah, with the pedestal pavers, luckily within the last year, maybe 2 years, manufacturers have been able to incorporate pedestal pavers. I won't give out any names, but incorporate pedestal pavers into their NOA assemblies. So now you got one pedestal paver manufacturer that's on a few waterproofing assemblies, and I can, we can now include it on projects. Before we had to do field testing and uplift and engineering to go through the product approval process.
Now I'm going to grill you back to what you just said before about how Florida's an all pretty much barrier system designed sort of market, and how having a pressure equalized system from a designer in California was a little bit of a rarity. Because I've had this debate, I can't tell you how many times, and I still don't have a straight answer. You have some designers and consultants that'll die for a pressure equalized system, rain screen only, and then some who are tried and true by the barrier system. And I think it is kind of climate driven, especially if you're on the West Coast and you don't have a lot of that wind driven rain. If you're in Vegas or something, or Texas, and you're not dealing with any of that. But how do you see the design in these barrier systems, like I said, upholding in wind driven rain events?
So
do they work?
I smile because I've been on both sides. I grew up with barrier systems professionally. I grew up inspecting them, and I didn't see any other way. If I didn't see a wet seal being applied on the perimeter of that window and a wet sealed glazing condition, that there's no way this can pass. So whenever I would see even preformed joint sealants, I couldn't wrap my brain around that. Up until maybe 3 or 4 years is when, because we're doing a lot more forensic, we're doing a lot of building hardening. So I'm going back to reseal buildings that were wet sealed 15 years ago or less. You can see that day 1, day 2, year 10, they're perfect. Beyond that, they don't work anymore. And I think that's the real difference. It's not that they don't work. They will pass with flying colors in a lab, a barrier system, because it's 50% of the design pressure. So it's very easy to pass a water test with a barrier system. What is the longevity. It's just not there as compared to a pressure equalized system. But for us,
a good quality sealant joint, especially if you have a dual stage or dual sealed system, shouldn't give you a good 20 plus years.
You said good quality sealant, properly installed, properly maintained, right? So there's all those, and one of the big factors for us is the UV. So we tear down materials with our UV drastically. Silicone, obviously, yes. Usually what I'm doing on most projects that are, stucco paint over a barrier system is I'm not touching the primary seal, I'm redoing the secondary seal, which most of the time was done in a urethane product, so it's already deteriorated, right? So they won't let me go back in there with a silicone, I'll do a urethane and then I'll paint over it and try to extend the life. So it's really material selection that's leading to this early decay.
I know you have a lot of concrete and precast, which is very durable from the opaque standpoint, but you're saying as long as it's designed so that you could easily replace those sealant joints, should be able to be maintained and last a very, very long time.
Yes. The difference is that, as you know, for your drainable pressure equalized systems, all your primary seals are inbound. There is no UV attacking them. There is no pest attacking them, that kind of thing. But then for us, it's a cost issue. And then who's installing your curtain walls? Union labor, I'm assuming. Not down.
A mix. Oh, you're saying all non-union there.
Exactly. So you get a very broad range of quality of workmanship. So we describe it as the Miami factor, basically. So I don't know a lot of local contractors that know how to install curtain wall. So again, you go through the testing process and you tested a barrier system, you're going to have to be paid a lot of money to go beyond that barrier system to go into a pressure equalized system.
I'm going to sound like a novice, but you keep mentioning stucco. What are challenges you run into with EIFS down there? Is it essentially the same thing? I know there's, and I see you smiling. I know there's a lot of it in the market, and maybe help me understand or educate me, because EIFS is a tremendous product in terms of thermal performance, and so you want to throw it on your lot line on a new construction job in New York. Great for compensating for a lot of that glazing area, but if you don't need it for the thermal sort of rating, and you're dealing in a high wind load, wind-driven rain climate, what are challenges you run into?
So I'm certain we're going to have to do a part 2 of this. So we're having a big internal and external come to reality moment with what we call stucco is direct applied stucco. It's literally CMU, concrete, and then you slap on ASTM C926 stucco scratch and brown coat, and then you paint it with, somebody's regular 3-year paint, basically. That is the South Florida standard. And then your insulation, your thermal control layer is inbound, and it's in between your furring strips for your drywall. That is 99% of your projects down here. That's what you're going to have. And then what you're going to see as you come down here is every one of these towers are redoing stucco every few years because it cracked right where the block met the concrete. It cracked wherever there was any movement. And again, these block walls are usually top and bottom anchored, so they're only lateral load or wind load from that matter, not overall building lateral load. The stucco is not designed for that, right? So what are we seeing with stucco is we as a company are trying to push people away from it as much as we can, but it is the design. You mentioned cost before. That's the cost that is being carried in every design here. I'm going to stucco this building. So what are we doing? We're trying to upgrade to at least provide control joints at all these similar material transitions. EFIS is one that we've recommended on projects, but we're running into that the insurance companies are not insuring people for EFIS. And I don't know if it's what I've been told by the industry is it's because of past EFIS failures. So everything from the 80s, 70s, maybe even 90s, where it was patty or patch applied, not drainable, no weather resistant barrier behind it, has failed, and therefore the insurance company don't want you to do EFIS. We obviously, what we are recommending is a drainable, weather resistant barrier system, single source manufacturer, fully bonded with vertical trowels. I mean, the whole, you know what I mean. And we like it, but we haven't been able to use it on more than one or two projects. We use it in a hospital, we use it in an office building. Most projects we're told by either the architect, builder, or developer, I'm not insured for it, I can't do it. So it's again, what I'm saying is we can't get away from it. I mean, we're hired on existing buildings where they say, my stucco's cracked, I want to repaint my building. And all I can do is say, here, do it again, exactly the same way you did it before. Call me in 10, 15 years because it's going to crack again in that time period, basically. So that one is, I don't know if I call it a pet peeve or just a big gorilla in the room for us right now in South Florida.
I'm going to cut us off because this is the first time ever in a podcast I looked and it's been over an hour and I didn't even realize what time it is. So next time we're going to cover investigative work, but this was awesome, very informative. Manny, what's the best way for people to get in contact with you, your firm, and where do you guys operate out of just Florida?
So facade.global would be the easiest website to type in, facade.global. I'm on LinkedIn a lot, both us and me and the company. Right now, we've got our office down here in Davie. We've got an address in Tampa. I've got a team over in Orlando. We've got an address in New York, but I don't have anybody physically there right now. And then we're doing work also in the Caribbean. So all over the place. I've got a team member going to China in a couple of weeks. So just pick up the phone, call us. We'll probably figure out a way to get there.
This is awesome. Thanks, Manny, again.
Thank you, sir, for the opportunity. I'll talk to you soon.